This is part 2 of the real number system. In part 1, we learned of the definition, examples, and relationship that exists between the different types of numbers in the real number system, such as natural numbers, whole numbers, integers, irrational numbers, and rational numbers. Now let us do a quick recap before we move on to part 2. For the first definition, it says this is a set of negative and positive whole numbers including 0. Which term fits that definition? Well, that will be integers. Second definition, this is a set of counting numbers. We naturally count from 1, and so that will be natural numbers. This is a set of numbers that cannot be written as a fraction whose numerator and denominator are integers. And that will be irrational numbers. This is a set of natural numbers including 0. That will be the set of whole numbers. And last, this is a set of numbers that can be written as a fraction and can be converted into decimals or from decimals back into fractions. And when we say fractions, we're talking about common fractions where the numerator and denominator are integers. That will be rational numbers. By the end of this video, students will learn how to classify numbers as even, odd, prime, or composite. They will also learn how to determine the factors as well as the multiples of natural numbers. They will learn as well how to determine the highest common factor as well as the lowest common multiple between numbers using several methods. And they will learn how to determine whether a number is a perfect number. The set of even numbers consists of natural numbers that can be exactly divided by 2. So the set of even numbers consists of numbers that are multiples of 2. Hence, even numbers are natural numbers ending with the digits 0, 2, 4, 6, or 8. The set of odd numbers consists of natural numbers that cannot be exactly divided by 2. The set of odd numbers consists of counting numbers that are not even numbers. So an odd number cannot be an even number. An even number cannot be an odd number. Hence, odd numbers are natural numbers ending with the digits 1, 3, 5, 7, or 9. Odd numbers. And these are some examples. Prime numbers. A prime number is a natural number which can only be divided exactly by itself and 1. Prime numbers have only 2 factors. Now here's a question. What is the first natural number that's a prime number? That's correct. That will be 2. Since 2 is actually equal to 1 times 2, notice that 2 has only 2 factors, so therefore it is a prime number. The next prime number will be 3. And 3 is equal to 1 times 3. So therefore 1 and 3, the only 2 factors of 3, making it a prime number. And notice with 2, that's what we mean by itself and 1. And we have 3. That's why I said itself and 1. So prime numbers have only itself and 1 as factors. A composite number is a number which has other factors besides itself and 1. Composite numbers have more than 2 factors. So if we look at natural numbers, 1 is not a prime number because only 1 times 1 gives us 1, but that's only one factor. It's not distinct factors. Prime numbers must have 2 distinct factors, itself and 1. So 1 only has 1 as a factor. So that's not a prime number. Composite numbers, though, have more than 2 factors. So let's take 4, for instance. We can get 4 by multiplying 1 times 4, as well as 2 times 2. So notice we have the factors 1, 2, and 4 as factors of 4. So since we have more than 2 distinct factors, then we will say that 4 is a composite number. 9, we have 1 times 9 as well as 3 times 3. So 1, 3, and 9 are factors of 9, making it a composite number since we have 3 distinct factors. Factors. A factor of a number is defined as an exact divisor of the given number. So let's look at some example. 3 times 5 is 15, hence 3 and 5 are factors of 15. 15 is therefore divisible by both 3 and 5. So we can say 15 divided by 3 gives us 5, and 15 divided by 5 gives us 3. 1 times 15 also gives us 15, not just 3 times 5. Hence, 1 and 5 are factors of 15. since 15 is divisible by both 15 and 1. So if A times B equals M, then A and B are factors of M, where A and B and M are integers, which implies that if M is divisible by both A and B, then A and B are factors of M, where A and B and M are integers. Note every number has itself and 1 as factors. Multiples. The multiples of a number are defined as a number that is obtained as the product of two numbers. For instance, if you look over this side, 15 is obtained from multiplying 3 and 5. Hence we can say 15 is a multiple of both of these numbers, 3 and 5. A multiple of a number A is defined as a number M that is obtained by multiplying A by a natural number B. Now we can think about the times table, and let's look at this example. Now if you notice that we have M is equal to B times A, so we're saying that M is a multiple of A. 5 is equal to 1 times 5, so we can say therefore that 5 is a multiple of 5. 10 is equal to 2 times 5, so therefore 10 is a multiple of 5. 15 is equal to 3 times 5, and therefore 15 is a multiple of 5. 20 is equal to 4 times 5. Therefore, 20 is a multiple of 5. And we can see the relationship between this equation here, where M is the multiple, as in 5, 10, 15, and 20 are multiples of 5. So M is a multiple of A, whereby B here represent the natural numbers 1, 2, 3, 4, and so forth. So if M is equal to B times A, where the quantity A is multiplied by the integer B, then M is a multiple of A. Perfect numbers. A number for which the sum of all its factors is equal to twice the number is called a perfect number. Let's put that in perspective. If we have 6, what are the factors of 6? We know that 1 times 6 give us 6. And we also know that 2 times 3 will give us 6. Hence, these are the factors of 6. Now, should we add these factors, we'll actually get 12. And 12 is actually twice the value of 6 itself. So the sum of the factors of 6 is twice the value of 6 itself, making 6 a perfect number. What about 28? We know that 1 times 28 gives us 28. We know that 2 times 14 gives us 28. And we also know that 4 times 7 gives us 28. Now, should we add these factors, we will actually get what amount? We'll actually get 56. Add these and see what you get. And 56 is twice the value of 28 itself, making 28 a perfect number. Are there any other perfect numbers? Properties of factors. There are some important properties of factors. 1 is a factor of every number, since every number is divisible by 1. Every natural number is a factor of itself, since every natural number can be divided by itself. Apart from 1, which has one factor, all other natural numbers have at least 2 factors. Every factor is less than or equal to the given number, meaning that the factors of a number individually will be less in value than the number itself. So let's look at an example quickly. If we have 7, what are the factors of 7? 1 and 7. 7 is equal in value to 7. But 1 is less than 7. We cannot have a factor of a number that's actually greater than the number itself. The number of factors of a given number is finite, meaning that if you can always list the number of factors. Factors can be evaluated using both multiplication and division method. Properties of multiples. Every multiple of a number is greater than or equal to the number. For example, multiples of 21 are 21, 42, 63, 84, 105. Notice that we keep adding 21 onto each number after. Here all the numbers are greater than or equal to 21. So the first multiple of a number is itself, which is where we have that multiple being equal to the number itself. But after that, since we're adding 21 onto itself each time, then those numbers will be greater than the original number. The number of multiples of a given number is infinite. For instance, in this example, if we keep adding 21, we'll go on forever. From the definition of multiples, we can say that an infinite number of integers can be multiplied by a given number to get the multiples, such that multiples of 25 is equal to 25, that's 1 times 25, 50, 2 times 25, 75, 3 times 25, 4 times 25 give 100, 5 times 25 give us 125, and so forth, because we keep on multiplying by an integer or a natural number each time. Every number is a multiple of the number itself. For instance, 23 is a multiple of 23, 30 is a multiple of 30, and so forth. HCF and LCM. HCF simply means highest common factor. The highest common factor of two or more numbers is the greatest of all their common factors. Therefore, it is called the greatest common factor or the greatest common divisor. If we say M is the highest common factor of P and Q, then M is the greatest possible number that divides both numbers P and Q exactly. For example, factors of 12 are 1, 2, 3, 4, 6, and 12. And factors of 16 are 1, 2, 4, 8, and 16. So we can definitely see the common factors of 12 and 16. These are 1, 2, 4. Do we have any more? No. So 1, 2, and 4 are common factors of 12 and 16. But what is the highest common factor? The highest one that's common to both 12 and 16. In other words, the highest number that divides both 12 and 16 is 4. Now, there are different methods that are defined to calculate the highest common factor of given numbers. There are 3 techniques that are frequently used to calculate the highest common factor of 2 or more numbers in mathematics. And these are 1. By listing the factors method, by prime factorization, and by division. Now, let's look at the first one, by listing the factors. Highest common factor of 32 and 24. So we list the factors of 32, which are 1 times 32 is 32, 2 times 16 is 32, and 4 times 8, which is 32. Hence, these are the factors. So we list the factors. We do the same for 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And then we select the highest common factor. The highest factor that's common to both 32 and 24. And as we can clearly see, 8 is the highest common factor, or factor that's common to both numbers. So therefore, the highest common factor of 32 and 24 is 8. Now, by prime factorization, let's look at that. The greatest common factor of given numbers can be found by the prime factorization method. Here, we need to express the given numbers as their product of prime factors and get the product of the smallest power of each common prime factors. Hence, we need to express the given numbers as their product of prime factors and get the product of the smallest power of each common prime factor. Let's understand this procedure with the help of the given example below. Let's look at the highest common factor of 36 and 84. By prime factorization, 36, we have 2 times 2 times 3 times 3. And we get 2 to the second power by 3 to the second power. Now, you may be wondering, okay, how do we go about getting this? Well, let's look at 36 somewhere here. Let's look at 36. Well, what do you know? What multiply what to give us 36? We know 1 times 36. We know 2 times 18. Now, so this is a prime number, since 2 has only 2 factors, but 8 is not a prime number. So we're going to split 18 up further. We can rewrite 18 as 2 times 9. Okay, so these two first factors are prime numbers, but 3 is not a prime number, it's a composite number. So we're going to split this up further. 9 can be written as 3 times 3. Hence, we can see that 2 times 2 is 2 to the second power, and 3 times 3 is 3 to the second power. So we have all prime numbers here. This is what we call prime factorization. Some person will use this method, take 36 and keep on dividing by prime numbers. Start with the first prime number, natural prime number, which is 2. 2 into 36 gives us 18. Let's try 2 again. 2 into 18 gives us 9. 2 cannot enter 9 without a remainder, so we go to 3, the next prime number. 3 into 9 goes 3 times, and 3 into 3 goes once. And so we have 2 times 2 times 3 times 3. Okay, let's look at the prime factorized into 84, and we do the same thing. So for 84, we say 2 into 84, and that will be 42. 2 into 42, that's 21. 2 cannot enter 21 because it ends with 1, because it's an odd number, so we go to the next prime number, which is 3. 3 into 21 goes 7 times, and 3 cannot enter 7, so we'll use 7 itself. Now 7 is actually a prime number itself, and 7 into 7 gives us 1. So we have 2 times 2, which is 2 squared, times 3, times 7. Now according to the method, what we need to do here, we get the product of the smallest power of each common prime factor. So we look at this, 2 to the second and 2 to the second. We get the product of the smallest power. So the smallest power among this, well, is just 2 to the second power itself. So we're going to use one of them. Among the 3 to the second and 3, we're going to use 3. Because 3 is really 3 to the first power. So we use 3. And 7, well, we don't have another 7 here, but we can think of this as 7 to the first power. And think of, well, we have nothing here, but we can think of there's a 1 here, which we can be written as 7 to the 0 power. So the smallest among 7 to the first and 7 to the 0, any number into the 0 power is 1. So I could afford to put a 1 here that would actually give me the same value. So I'll use 7 to the 0 power, which is really 1. So this is going to be 2 to the second, which is 4. 3 to the 1 is 3. And 7 to the 0 power is really 1. And 4 threes is 12. So 12 is the highest common factor of 36 and 84. 36 is divisible by 12, and 84 is divisible by 12, because 7 12s is 84. So now 12 is the highest number that can divide both 36 and 84 at the same time. HCF by the division method. Now this method may be a little bit complicated, but I said the division method of finding the highest common factor is simple and can be performed quickly. Go to the steps below given to find the highest common factor of the given two numbers using division. Step 1. Here we have step 2 and step 3. You may read these. So here's what we're going to do. We want to find the highest common factor of 18 and 24. It says divide the largest number by the smallest one among the given two numbers. So we have 24, which is the largest. We know that 24 is greater than 18. So we are going to divide the largest, which is 24, by the smallest. So we carry out step 1. 18 can enter 24 only once, and 18 times 1 is 18. And we're going to subtract, and we will get 6. 6 is the remainder. It says check the remainder. If it is not 0, here the remainder is not 0, then make it the new divisor. So this will be 6 will be our new divisor, and write the previous divisor as the new dividend. So 18, which is the previous divisor, will become the dividend, and 6, the remainder, will be the new divisor. 6 goes into 18 3 times, and 3 times 6, or 6 times 3, is 18. Then we're going to subtract, and we'll get 0. Now it says here, once we get 0, if it's equal to 0, then the last divisor will be the HCF, the highest common factor of the two given numbers. So 6 is our last divisor, hence it is the HCF, highest common factor of both 18 and 24. LCM, which means the lowest common multiple or least common multiple. The least common multiple, LCM, is a method to find the smallest common multiple between any two or more numbers. A common multiple is a number which is a multiple of two or more numbers. LCM denotes the least common multiple of any two or more given numbers. Now, if we consider the multiples of 16 and 20, we get these multiples. Remember, every number is a multiple of itself, and 16 is the first multiple of 16, which is 1 times 16. 2 times 16 is 32, 3 times 16 is 48, 4 times 16 is 64, etc. And if we look at 20, 1 times 20 is 20, 2 times 20 is 40, 3 times 20 is 60, 4 times 20 is 80. Notice that we have our first common multiple. The first common multiple that we find for the two numbers is the least common multiple, since there are other common multiples of 16 and 20. But we stop at the first one we find. And the other method we're looking at is prime factorization. Some people will see this as a little easier, perhaps, especially if you're struggling with highest common factor. So let's look at that one. So we find the prime factorize 21 according to what we do here. So we're gonna divide by the first prime number that can enter 21 is 3. Goes 7 times. And the next prime number we're gonna use is 7 because only 7 can enter 7 as a prime number. And so prime factorize 21, we get 3 times 7. Alright. We prime factorize the next number, which is 36. We divide by 2, get 18. Divide by 2, we get 9. And the only prime number that can enter 9 will be 3. And 3, only prime number can enter itself. And so prime factorizing 36, we get 2 times 2, then 3 times 3. And what we want to do is to select the highest number of times a number occurs in both sets. So if you look at 2 occurs the most in this set. It does not occur in this at all. So we're looking at 2 times 2. And 3 occurs the most in this set. Only occurs once in that. And 7 occurs the most in this set. Does not occur in this. And this will be your answer for the LCM. 2 2s, that's 4. 3 3s is 9 times 7. 4 9s is 36. And 36 times 7 is equal to 252. And there's another method that we could actually use. Let's look at that method. And that method is using a formula. The LCM of A and B can be found by multiplying A by B and then divide by the highest common factor of A and B. So the LCM of 21 and 36 can be found by multiplying 21 by 36. A little complicated multiplying, but check this out. When we find the highest common factor of 21 and 36, the highest common factor is 3. 3 is the highest number that can enter 21 and 36. Because if you look at the factors of 21, we have 3 and 7. We know that 7 cannot enter 36, right? But we know that 3 can enter 36. The 3 is the highest common factor of 21 and 36. 3 goes into 3 once, and 3 can go into 21 7 times. And so now 7 times 36 will actually give us our 252. All right, if you're not sure about that, 36 times 7, 7 6 is 42, 7 3 is 21, plus 4, 25.